In this section, we're going to look at slopes of lines and segments. We're going to break this up into two parts. In part one, we're going to look at slope algebraically. So we'll have a graph or a table or an equation, and then ask you to find the slope from that. And then we'll do some applications with that. In part two, we're going to go ahead and take a look at slope in context as an average rate of change, how it's very similar, but how we have to be very careful with the context itself. So in the warm-up here, we're asked to classify the slope of each line as negative, positive, undefined, or zero. So if we look at the first line here, slope is the amount of vertical change over the amount of horizontal change. If I look at this line right here, it is not moving up or down. It's just staying level. So the vertical change in this case would be 0. The horizontal change really depends on what points we pick. If we were to pick these 2 points right here, let's say the horizontal change is 3, we know that that has a 0 slope. On number 2, we don't need to calculate the slope, but we can tell what it's doing. As we move from left to right, this line is falling. So the vertical change would be a negative as we have a positive horizontal change. So that would be a negative slope. On number 3, kind of similar to number 1, it's one of those special cases, but instead of moving horizontally, this line is moving vertically up and down. So there's not any movement to the left or the right. So let's say we pick 2 points here like negative 7, 0 and negative 7, 2. Our vertical change in that case would be 2, and our horizontal change would be 0. We can't divide by 0, so we have an issue where we have an undefined quantity. So if you have a vertical line, your slope's undefined. And then number 4, we can see from the left to the right the graph is increasing. So the vertical change is positive as well as the horizontal change, which would give us a positive slope. It's very important that we're able to distinguish those four as we move forward. So let's take a look at some problems where we actually have to calculate the slope, find the actual number. So as we're saying here, slope is the amount of vertical change over the amount of horizontal change. You might want to think of this in terms of functions, the amount of change in the output over the amount of change of the input. Again, vertical coordinates are the outputs, horizontal coordinates are inputs. So what we're going to do is we're going to pick two nice convenient points here. So I'm going to pick this guy right here, 0, 2. If I can actually grab the pen, there we go, 0, 2. And then also at negative 4, 0. And what I want to do is figure out what is my vertical change. How much should I move up or down? In this case, I'm moving up 2. And then I want to find the horizontal change. Well, I'm going to write this out. 2 over. And let's just do blue here. And it looks like from negative 4, 0, we have a plus 4. So my slope then would be 2 over 4, which I can reduce down to 1 over 2. And number 2, we already looked at that at the warm-up. We know that a horizontal line will have a 0 slope. Again, number 3, I'm going to pick two convenient points. So I'm going to pick 0, 0 is a nice point. And this looks like a good point here at 1, negative 5. So I'm going to find the vertical change. So it looks like we're dropping 5. So that's a minus 5. And then our horizontal change is a plus 1. Okay, so our slope then would be negative 5 over, there it goes, over 1. And so we're going to know that slope better if we reduce that down as just negative 5. All right, so that's from the graph. Pick 2 points that are convenient, that are a nice intersection points, and find the slope using your vertical change over your horizontal change. When we have these tables, it's a similar idea, but they're giving us a lot of points that we can use, so we're going to pick whichever ones we want. In general, I'm going to pick the easiest ones, and if I can't make a decision, I'm just going to start at the beginning. But it's a little flip-flopped here because the y and the v of t and the f of x, the outputs are all on the bottom. So you're thinking that it's the change in x over change in y. It's not. It's change in y over change in x. So we're going to use the same strategy here. So in red, we're going to do that y coordinates. So our y from 1 to 3, that's a plus 2. So I'm going to write it as 2 over. And then for our x's, for the same values, from 2 to 8, I have a plus 6. And then 2 over 6 gets me a third. And I do the same thing for v of t. We'll do this one and kind of move on to the next part here, where we have a 32 to negative 26. That's a minus 6. So a minus 6 over. And then from negative 2 to 2, we have a plus 4. So our slope then, negative 6 over 4, when we reduce that down, is negative 3 over 2. Then we have equations, and really 3 different types of equations. One of them is in point-slope form, one of them is in slope-intercept form, and then one of them is just y equals something. And we'll talk about each of those 3. When we have point-slope form, this is our general form for point-slope. Y minus y1 equals m, that's a better m, times x minus x1. This value right here, m, is your slope. So based on number 7, my slope is 1/2. Number 8 is in the slope-intercept form. Y equals mx plus b. And just like on the previous question, m is your slope. So looking at number 8, m is in front of x. It's that number negative 19. 9, believe it or not, is in slope-intercept form, but it looks different because I don't see an x. Well, the reality is that that's y equals 0x minus 7. So based on that, my slope has to be 0. And in reality here, this is just a horizontal line. So if I were to graph this, it would look something like this at negative 7. We know horizontal lines have a 0 slope. All right, so let's take a look at number 12. This is a kind of tough question. I want to make sure we address this one here. It says a line with slope of 3 over 2 passes through the point a comma 6, 7 comma 12, and 15 comma b. And what we want to do is find the value of a plus b. So I'm going to start by writing out 2 points, a comma 6 and 7 comma 12. What I need to do is find the slope between these points. But I already know what it is. I already know it's 3 over 2. Here's how I'm going to do this. I'm going to say, let's find the change in y. That's a plus 6. I don't know what the change in x is, but I can find it. And here's how I'm going to find it. I'm going to take this value here, the 3 over 2, and I'm going to set that equal to 6 over a question mark. I'm not sure what that actually is. So think about this way. If we're going to solve this, 3/2 is the same thing as 6 over 4. So if we have a vertical change of plus 6 and my slope is 3/2, then my horizontal change has to be a plus 4. So if I started at a and added 4, I get to 7. I can set up an equation for that. A plus 4 equals 7. When I take away 4, I get 3. I'm going to do the same thing to find b. So we've got 7, 12, and 15 comma b. In this case, I know the horizontal change, but I'm still going to follow a very similar strategy. So from 7 to 15 is a plus 8, and then in the red, I don't know what that is yet, so I'm going to find it in just a minute. But I know that my equation that I'm going to set up, my proportion here, is going to be 3 over 2 equals question mark over 8. Now to get from 2 to 8, I'm going to multiply by 4. I would have to do the same thing in the top to maintain that, so that's got to be a 12 there. What that means then for my change, my vertical coordinate change, is I have to have a plus 12. And so 12 plus 12 equals b. B is 24. So I'm trying to find a plus b. I've already got the two values. 24 plus 3 is 27. 13, we have a point, 7 comma 1, and we want to find two other points that must lie on the line. And they can really be any points as long as they're actually on that line, so there's a lot of different possibilities for this one. We're going to start with the point 7 comma 1. The slope of negative 2/3 means I'm going to have a change of negative 2 in the y, so I'm going to do this here, negative 2 for every plus 3 in the x. So when I take 7 plus 3, I get 10. And when I take 1 minus 2, I get negative 1. So there's 1 point that would be on that line. I can continue that pattern. So again, do a negative 2 here. So negative 1 minus 2 would be negative 3. And then extend my pattern of plus 3 in the x. 10 plus 3 is 13. So now I have my 2 points, 10, negative 1, and 13, negative 3. And again, that's slope algebraically. In part 2, we're going to look at slope as an average rate of change.